Good morning, everyone. My name is Allan Joseph Romero. I'm a PhD student of Dr. Mohammed Mustafa. I came from University of Nevada, Reno. But before I start my presentation, I just wanted to acknowledge all the industry support that we got for this project. First, for the two precasters that we work with, Jensen Precast and Confab California. We work with the UHPC Cortov and also donation from the AdMix from SICA. And also some agencies that we work with from ABC, UTC, and also PCI West. So for today's presentation, I will be discussing the sustainable UHPC with recycled steel fibers for structural columns. So before I wanted to start things that I did, I wanted to start where we are right now in UHPC. We are growing $1 billion projecting in the next 7 years, probably going to be much sooner if we do diligently working with UHPC in the industry. So in terms of bridges, I know these numbers are not up to date. It's only 2019, but pretty much we had UHPC growth in the bridges already, pretty much on the East Coast. We are trying our best to go for the West Coast as well, but we have to start somewhere, right? And mostly the applications that we see is that pretty much all the UHPC that had been done are pretty much from the joint parts or the overlays, and we wanted to go more from that. So what are the current issues that we see? We know UHPC is growing, it's promising, but it still has limitations on it. What are the things that we saw from the industry? They always say, you know, how expensive UHPC is if we're going to use it for large-scale applications. Also, there's a lot of limited study. Of course, we know that ACI and also PCI have released guidelines on how to use UHPC, but we still need more guidelines, especially on how to use it for bridges. Will the UHPC still perform in the same way as in columns, you know? And also, there's a lack of research in terms of like sustainable materials. If we can make it, you know, sustainable and it's cheaper, that would be amazing. So, we know that part of the component of UHPC is that it uses steel fibers. And this steel fibers is pretty much accounting for almost 7% of the carbon emissions. So we wanted to at least lower that part. And what we found out is that if we actually, those tires that you drive on every day, that tires gets in the landfill. And pretty much we reproduce 1 billion of these tires that goes to the landfill. And if those tires can be harnessed, and if we can get those steel fibers, that's accounting for almost 12 to 21%. So if the question now is, can we actually introduce these recycled steel fibers into UHPC? So these are the knowledge gap that we wanted to ask. So the first question is the general question, will recycled fiber work as an alternative for manufactured fibers? So can we go from the material level and actually examine if the type of the recycled steel fiber in terms of the aspect ratio, can we use high aspect ratio, can we lose low aspect ratio in terms of like mixing, will it affect the mixer type? Can we actually mix the UHPC with recycled fibers in a high shear mixer or a truck mixer? Also the mechanical properties, it's very important for flexure and the strength. And the tensile strength, because of the recycled fiber, it's not going to be as great as manufactured fiber, but can it actually still be as an alternative? And we wanted to go from the structural level, from the full-scale precast UHPC columns for just axial purposes, and then after that, go from the seismic for both axial and bending. So we go, I started doing the mechanical characterization 3 years ago. I developed around 1,500 cylinders that I tested through compression, around 500 dog bones for tensile tests, and also around 550 for flexural testing. So what are the key findings that we saw on this is that we saw that high aspect ratio is going to have a lot of problem in terms of fiber mixing. So we're going to see a lot of segregation. We have to limit the fiber volume up to 1.6%. But if you actually use a low aspect ratio, you can up to go more than 6%. If you have a shorter fibers, you can go with that. But we saw that the compressive strength, it's going to be just 10 to 20% difference in terms of compressive strength compared to the manufactured fibers. It's not as bad, but you know we will see a decrease, of course, with the compressive strength. And also the aspect ratio, we saw that if we actually use a low aspect ratio for the recycled fiber, it's going to affect a lot the flexural strength. So again, it's an optimization thing that if you use high aspect ratio, you're going to have a lot of fiber segregation issue, but you still want to have that flexural strength, so that's why you have to meet halfway for it. And also, we saw that high shear mixer works for recycled fiber, but truck mixing, you're going to see a video later on what we're going to observe on the truck mixing part. So we went to, after we did the mechanical characterization, we went from the full-scale columns. So I developed 5 full-scale columns. The dimensions are 9 feet tall, and the cross-section is 12-inch by 12-inch. So these specimens were varied in terms of the confinement type. So we chose more confined or less confined, and also the fiber type, compared the manufactured fibers with the recycled fibers, and also the fiber volume. Can we go from 2% fiber to 1% fiber? Because it's just pure axle, right? So technically the fibers isn't going to be too crucial. So we shipped this column. I mixed this on our yard with a high shear mixer. We developed like 5 per each batch. So it took a lot of time. I got a help from my colleague that time. So we shipped these columns and went to the UC Berkeley with the brick press machine. I don't know if you know that machine that they have. It's a big one that can test high axial columns. And what are the key findings that we saw is that pretty much all the failure are spalling, tire rupturing, buckling of the longitudinal reinforcement. We saw that the proper confinement is still needed for UHPC under pure axial loading, and also the difference in the axial strength for manufactured fibers and the recycled fibers are pretty much no difference. So, I mean, I guess we saw that the fibers isn't that very crucial. But we saw also that if we reduce the fiber volume by 1%, we saw that the axial strength is around by 9.5%, but 9.5%, if you actually look at it in a structural level purposes, is not as much. So if we can actually get away with using 1% volume, we kind of save us money, right? So now we go and went through my last project. It's UHPC in accelerated bridge construction. The first question we asked, why ABC? My answer is why not, right? Because it saves us money. It has a better quality control, safety advantages, and convenience for travelers. Pretty much the UHPC that's been done for ABC is pretty much for connections, for overlays, and such like that. So we wanted to go for more than that. So the question is that, can we actually demonstrate this in a large-scale testing? The question also is that, will UHPC recycled fiber, going to mix in a precast setup, or does UHPC have the same behavior as, for ABC columns? So this timeline of the project, we started constructing 10 of these seismic columns in Confab. They are a precaster in California. So we finished by around March and April 2023. We build the footings that's going to be the foundation for these columns by August of 2023 through the help of Jensen Precast. And last, we assembled these columns by October 2023 on our own fabrication yard. And lastly, we tested this recently by November 2023 up to January 2024 with these 10 columns under quasi-static and shake table that we have in UNR. So these are the 10 matrix that we have. I said we have 10 columns. These are pretty much 1/3 scale of a typical bridge specimen. We didn't follow, this is not a design based on an existing bridge. It's just a specimen that is typically tested in our shake table or in our laboratory, I mean. And the specimens were pretty much varied in terms of like the fiber type, the connection detailing in the material, and also the loading protocol. So I said earlier that we developed columns that have recycled fibers on it, 4 of them. And these are identical from the manufacturer's fibers that we have to also compare the performance. And also the 2 columns that are pretty much normal strength concrete based on the Confab California cement that they use, concrete, I mean, that they use. So this is what we started. We developed the columns. We assembled the reinforcement. We put a lot of strain gauges to see all the strains. They put one of their precast bed and formed the column formworks. And this is the final part that we put the formworks around before the mixing. So I'm going to show you a video of how we did our mixing. So first, started putting the quart of powder into the truck mixer. We use their own sand and cement that is in line with what their production is.
Stopped, and then after that,
You
I
will
got another
see.
one started again.
Sorry for the background.
And some of the sand that we use, so they're in line with.
This is the control room where we put our, we control the sand, the cement, and the admix into the truck. This is the admix that it's not part of their system because they don't normally use this admix, so it's pretty much for UHPC. We tried to use the hopper because they don't have a mechanism to disperse the fibers, but it wasn't as successfully. You'll see a video we're trying to.
Is that everything?
It really didn't work. So we have to manually put it on our hands. And you will see.
Yeah, do that.
I don't think we put a video on it. But this is the part that we put the recycled fiber. You see how fluffy they are. We have to manually disperse it. It's around by 15 because 15 minutes we're too slow because we're just putting the fiber. Yeah. So this is what it went out in the UHPC truck for the manufactured fibers. So it has a good flowability around 8 to 9 inches. I think it's around 8 to 9. So this is another view when we're putting the UHPC on top of the loading head. So if you can see all the thing, when it goes down, there's no reinforcement blocking it, so it just goes through. So this is the part that we saw from the recycled fiber. It has some fiber segregation. We did mix them in a high shear mix and we found out it's okay, but of course we get surprised when we're mixing that, you know, for truck mixing is a little bit segregation. But again, when we were putting it in the column, we didn't have any issues because it's just hollow that goes into the column. So we didn't have that kind of fibers going into the reinforcement. Okay, so we also developed the footing in Jensen precast. This is just normal concrete, typical for like ABC, just socket and duct connection. So we assembled them, delivered the 10 columns into our yard with also the footings. We assembled them myself with some help of a grad students and also undergrads. I saw a picture later. But for the testing part, we did the cyclic testing. 7 of them are under quasi-static cyclic testing. We use an actuator with 110 kits to reach around 0.25 drift ratio to 12%. Only one column reached around 12% drift ratio, and which is funny. It's the recycled fiber in this case, which I will explain later why we actually think it achieved much better. But pretty much this is the loading protocol that we have. And also, pretty much we wanted to also try the dynamic part also with using our shake table. We did 3 columns that are under shake table testing, and we simulated the 1994 Northridge earthquake from 25 to 200%. We didn't reach 200%, we only reached around 175 until we break it. So this is the video of what we did with the shake table. This is 150% of the shake table test that we had. So it didn't fail at this one. You're going to see a little bit of cliff that we failed after in 175%. So this is 175. So pretty much you just failed the column, rupturing the reinforcement. Okay, so this is a visual damage that we had. So we saw that the recycled fiber pretty much did a very good job in the plastic hinge. We saw a lot of damages. We still see some of the spalls that are still attached because of the fiber. They're very good in the macro part to hold the cracks in. But pretty typical failure, we saw like bar buckling, tire rupturing, and also some major spalling that we had. It's pretty much different from the manufactured fiber. You see a wide crack localization on that part in the plastic hinge. We kind of expect, because a lot of trend now, we see that the crack localization happens on failure of UHPC. Pretty much if we use, this is for socket connection, by the way. For the duct connection, we saw that pretty much because the column is so, my argument, it was pretty stiff, so that's why we see that the failure happened at the interface where the reinforcement rupture at that point. So again, this is just a month ago testing, so we only have preliminary findings, but pretty much what we saw is that the recycled fiber has a good energy dissipation. This is just one example of the hysteresis tube that we got. And also the overall, like the backbone curves from all the testing, you can see the trend. The broken lines are pretty much from the recycled fiber, the solid lines are from the manufactured fiber, and the two are from the normal concrete. So what are the conclusions for this project? We saw that, recycled fiber has a good potential for alternative for manufactured fiber. Aspect ratio is very important for tensile and flexure. Again, it's going to be very susceptible for fiber segregation if you use higher aspect ratio. And also for recycled steel fibers to work in pure axial columns, it's going to work. And lastly, for seismic bridges, it's pretty promising. It has a good energy dissipation and high ductility achieved. So thank you, everyone. I know I rush everything because we are under time. So thank you.
Thank you.